Welcome to Code Astro 2026, everyone. We're so excited to have you here. This is my favorite week of the year, and it's the seventh year of the workshop, so it's grown and changed a lot. It somehow manages to still be really chaotic every year, so we're very excited for the chaos too. So if you can find your project groups, try to sit with them if you're in person right now. Otherwise, at the first break, we'll give you a chance to also try to find your project groups. All right, so I want to start off with a little bit of motivation of why does this workshop exist. So most astronomers have no formal education in programming, including many of us, meaning the instructors and the TAs in the room. So this is bad for astronomy as an endeavor. It causes bugs in code, poorly documented or hard to read code, code that isn't reproducible, and inefficient code. But beyond it just being bad for the field of astronomy, it's also bad for us as individuals. Every year, Jason and I read applications for Code Astro, and a really common theme that comes up year after year after year is, I feel really bad, I feel behind, I don't feel like I can program at the level that I should be able to, given where I am in my undergrad program, PhD program, professorship, etc. So this is a very big problem in our field, but it's also a very fixable problem. So you don't have to major in computer science to learn to write good code. So the point of this workshop is to try to help you develop the habits of excellent software developers, so you have that confidence to go back into your research life and write good code. So I want to start off also with a land acknowledgement. So the land on which we gather here in Santa Cruz is the unceded territory of the Awaswas-speaking Yupi tribe. The Amamutsan tribal band, composed of the descendants of indigenous people taken to Mission Santa Cruz and San Juan Bautista during Spanish colonization of the Central Coast, is today working hard to restore traditional stewardship practices on these lands and heal from this historical trauma. If you want to learn more about the land acknowledgement or about Santa Cruz, you can check out this link here. All right, so the goals for this workshop overall are, by the end of this workshop, you'll be able to use the language of software development, develop and release an open source astronomy package from start to finish, and write code that follows best practices of software development. You're going to get very familiar with these goals. I'm going to show you them at the beginning of every day. There's a lot of information and links in the workshop. So a couple years ago, we created this cheat sheet that I recommend that you bookmark on your computer. So if you Google search Code Astro and then look for this workshopinfo.md file, or you just go directly to this link, there's this cheat sheet here that shows you everything you might need for the workshop: the code of conduct, the website, GitHub, blah, blah, blah. I'm going to go through all these things, but I just want to point out that this exists too. All right. One of the links that's on that list is a class and TA sourced vocabulary doc. So we keep track of relevant vocabulary here. And if you hear a word that you don't recognize at any time in the workshop, you can add a comment that says, hey, I don't know this word, can you please add a definition for it? This document has been compiled over the last 7 years. So every time someone didn't understand something over that period, we added stuff. And it's grown and changed a lot. So it's a really great resource now, but I'm sure there will be new words this year, as there always are. So please feel free to use it interactively. All right, so a couple of logistics. Classes are going to be hybrid over Zoom and in person. On Zoom, please mute yourself when you're not speaking. You're welcome to turn on your video, but it's optional. We're also going to record the classes and distribute them afterward. I'll post the link to the recordings in Discord as soon as they're ready every day. We're also live streaming to YouTube, and the link to the YouTube live stream has also been posted in the Discord. So a typical schedule for Pacific time zone, not Central time zone, is 9 a.m. to 12 p.m. We'll have lectures over Zoom and in person, and also interactive exercises. We've tried, it's not going to be 3 hours of lecture. When we started this, it was 2020. And so Jason and I were like, all right, the longest people are going to pay attention is the length of a YouTube video. So we don't want things to be longer than like 20 minutes. We don't always exactly stick to that. Like sometimes it's longer, but it's not 3 hours in a row. After this like in-person all-together time, You've got unstructured time from 1 p.m. to 5 p.m. Pacific time if you're in person. You can use this time to finish in-class exercises, work through Jupyter notebooks that we'll distribute more carefully, and also work on your group project, which I'm going to introduce more carefully in a sec. We also have a couple of bonus lectures during this 1 p.m. to 5 p.m. block. They're all optional, so you don't have to go, but you can like pick and choose what you think would be the most relevant for you. Wednesday afternoon, we've purposefully not scheduled anything, so we don't have, there's no built-in time to work on your project, and there's no optional activities. So you can, no optional lessons. So you can use this time to explore Santa Cruz, social activities, or you can just rest and recover, whatever you choose to do. I think at this point, most of you have been assigned to a project group, and each project group has its own designated teaching assistant. So we're going to ask the group to meet with their TA at least once per day. The designated times, the default times are 8 a.m. Pacific time if you're remote, and 1 p.m. Pacific time if you're in person. So if this time doesn't work for your TA or anyone in your group, it's your responsibility to change this meeting time. But if you don't hear from anyone, assume that you will meet with your TA at 1 p.m. or 8 a.m. You should also communicate with your group and your assigned TA via Discord. So on Discord, you should have been added to a group 12 or whatever channel. If you haven't done that, it's because either you're not assigned to a group yet, or you haven't filled out your Discord handle at this list of group names here. So this is this link that takes you to the whole list of groups for this year. So please feel free to reach out if you have any questions about group logistics. Yeah, that's what the expectation is. We're also often going to put you into breakout rooms on Zoom, or like breakout rooms in person to work on activities in small groups. Over the course of the workshop, we've tried out many different ways of doing this. We originally had people like move and work with different people each time in these breakout rooms. We found that the majority of people preferred to work with their group participants throughout the whole week. But if you don't want to do that, if you want to instead like work with different people every time, you can let us know and we can help you like coordinate that. So send us a message. But by default, you'll be expected to work with the people in your group on all of these like in-class breakout activities. Also, importantly, if you want to change your group at any time for any reason, you can notify us. This option's open now and remains open throughout the workshop. You also, every year people like write these long justifications to me about why they want to change their group. You don't need to write anything. You can just say, I want to change my group. If you have another group in mind, just let me know. If you don't, I'll help you change. Okay, so in-person logistics. We've got a map at this link here. So you can also find this if you Google code Astro. The first link that pops up is the website. And then if you go here to details, by the way, also this really sick little like Explorer thing was a Code Astro project in a previous year.
Yep. Sorry, can you tell me how to get to these earlier pages you were showing from this site?
Yeah, great question. So these are all on the GitHub. So the GitHub is accessible from this link here. So again, if you go Code Astro, and then click on the GitHub, it'll take you to GitHub. And then I'm going to talk a little bit more about the organization of this in a couple slides, but just to take you through it for now. On day one, if you scroll down, we've got a link to the welcome slides here. So that'll take you to this presentation. Okay, so there's a detailed agenda here with locations and stuff. We've also got a designated quiet room for the entirety of the workshop, and that's Oaks 101, which is one of the small classrooms that's just over there. So if at any time you need a quiet space, you can go there. So if you're on Zoom, please feel free to use all the Zoom, like usual Zoom interaction tools. You can down here. There's also an Ask in breakout rooms that you can click to make sure that we send a TA or someone else to help you with whatever you're dealing with. All right, so you all should have also joined Discord. Discord is going to be the main place where we communicate, where you communicate with your groups, where we send announcements about the workshop, sort of just general chatting stuff. So if you you can change your nickname on Discord to your real name so that people don't see your username of like bluesy3303 or whatever. You can also optionally add your pronouns here. If you have any questions about Discord, our Discord czars are David and Ray, and here are their Discord handles. Ray's right there for the folks in person.
Yeah. So if you have Discord problems and you get changed for group stuff, come find me.
Thanks, Ray. We also have an anonymous feedback form. This is different from an also anonymous feedback form that we'll send you at the very end of the workshop to see how everything went overall. This is totally optional, but you can fill this out as many times as you want, as like every day or multiple times a day if you prefer. So our goal is that we want a continuous stream of feedback about how things are going. So this can be anything from like, I feel uncomfortable for XYZ reason to like, hey, the lights are too bright. Can you change the lights? And people in the past have used this very well, and we've been able to like adjust locations of things, distractions, all that sort of stuff in basically real time. So we really encourage you to use this feedback form. And I'll remind you about this once a day. All right, so I talked a little bit about the website and the schedule already. So the two main like primary links for the workshop that everything else is linked from are the course website. So that's the one that I got to by just Googling Code Astro before. There's the complete schedule. We actually aren't doing office hours this year, so never mind about that. And then the course GitHub, which you can also access from the website. You can also access the website from the GitHub. All of the course materials are here in the GitHub. They're organized by day of the workshop. So today is day 1, so all the stuff that we're going to be doing is in this day 1 folder. There's also a README in each day's folder with project goals and lecture materials. So that's sort of like the place to start for like what we're going to do on a given day. So just to orient you there again a little bit, organized by day, we go into day 1. If you scroll down, you'll see the README. So you can see the project goal for today, the learning objectives for today, and then all the useful links. So that'll be like lecture materials and stuff. The README is also here, so if you want to see it by itself, you can click on it. All right, so let's talk a little bit more about the project. There's more info about the project at this link here if you're looking in the intro slides. So the goal of the project is by the end of the week, you're going to have developed and released a fully documented, well-tested, and open source Python package. You're going to work with 1 to 3 others on this project. We encourage you today to use some of the unstructured time to brainstorm and decide on an idea. All of your TAs have really, really great feedback, and especially this year, I think the TAs have thought a lot about like how to, like what makes a good project, how to scope a good project. So I really encourage you to talk to them about advice for the project. Some things in general, some ideas for the project are you could do something related to your research. Generally, you want this to be a relatively small task because the purpose of the project is not really the task itself, but all of the like infrastructure surrounding the task. So writing tests and like actually doing your pip install and stuff like that. So you don't want like a whole pipeline to be released open source this week. You want one thing. You could also work on some visualization software, or you could process an image in some way. If you go to the, what's it called? The like poster session, I think?
Oh, poster session,
yeah. There's a channel in the Discord called Poster Session, which is all where people in previous years have shown off their projects. So that's like a pretty inexhaustible source of past Code Astro projects that you can check out for inspiration. All right, again, some advice for the project. Like I said before, limit the scope of the project. Most of your time is going to be spent writing docs and tests. It's okay for the main code to be pretty short. As I mentioned a couple slides ago, check in with your group's TA at least once a day. It doesn't need to be perfect. Keep focused on the project goals each day rather than worrying too much about the actual functionality of the package. I'm going to go over the timeline on the next slide. And so this is related to the timeline. We're expecting you to spend, we've designed this course so that you should spend 10 hours on the project over the course of this week. So it's a good idea to make a timeline for what you want to do for the project. So here's an example 10-hour plan. On day one, you might spend 30 minutes deciding on the purpose of the package with your team, brainstorming and zeroing in on a demonstrable feature, setting up a project repository, or like where the project lives, and then writing one central function. So that'll be most of your time today on day one. On day two, you want to really get the project working. So fix bugs, get a feature working. You might spend 1 hour on that day. And then attending optional lessons. You can then spend 2 hours documenting and pip packaging your code on day 3. And then writing testing modules for about an hour on day 4. And then another hour fixing bugs, adding extra features and polishing documentation on day 4. Again, this is not like the schedule you have to follow. This is a suggested schedule, but it's a good idea to make one of these with your group mates. On the last day, we're going to have optional project presentations. So for the first 60 minutes of the presentation time slot, you can optionally present to the whole conference. This is really, really fun. Everybody gets 5 minutes. You can do whatever you want for your presentation. So you can do a demo of your code, you can do slides. Sometimes people make like YouTube advertisements for their package. Like you can go crazy. It's really fun. You then for the next 30 minutes, we're gonna, this part is not, it's not optional. I always say that everything is in Code Astro is optional. Like nobody's forcing you to be here. You're not getting a grade at the end. So if you don't want to do something, you don't have to do it. But this is like a thing that we will do unless you tell us you don't want to do it, is that you swap projects with another group. So spoiler alert, it's not going to work. Like your code isn't going to pip install on someone else's computer the first time, and like they're going to encounter bugs, and it's going to be ridiculous and chaotic. But you learn a lot from seeing someone actually try to interact with your code in real time. There's a sign up sheet here. I'm realizing I forgot to check if this was the right one. So this might be the one from last year. Okay, yeah, that's the one from last year. That's okay. Well, so don't go to that one. We're going to remind you about this on Thursday, about the project sign up, so don't worry about this now. Okay, I also want to give you some advice about how to work in groups. I'm a person that when I was in school, I really didn't like group work, and I kind of just took my computer and would squirrel myself away and be like, I'm going to do this thing, and you guys work on this other thing, and at the end, we'll put everything together. My best experiences with group work have been working with Jason. When Jason and I wrote Orbitize, we did it using this pair programming paradigm. And that was sort of the first time in my life when I was like, oh, okay, I understand why group work can be helpful. So we want you to try to use this pair programming paradigm this week. It's probably going to be difficult at the beginning. It'll take a day or two to get used to it, but I really encourage you to push through that discomfort and try to get this to work out. And I think by day 3 or 4, you'll find that this is actually really helpful. So how does pair programming work? One person's the driver who's actually going to be typing code, and then the second person is the navigator who watches what gets typed and offers directions. So the driver is thinking more about small scale stuff. So having the right syntax and making sure that the code actually works. The navigator is going to think more big picture about the overall functionality of the code and how this piece of code is related to other things that you're doing. The key is that you want to switch back and forth on some regular time scale. So for example, you could do this every 10 minutes and set a timer so that you switch off. You could also do it we're going to write 4 functions. I'm going to be driver for the first function. You'll be driver for the second function. In 3-person groups, 2 people are navigators, so on and so forth. If you have 4-person group, 3 people are navigators. But generally, we try to keep Code Astro groups small for this reason. We want people to practice this pair or triple programming paradigm. If you're working with people over remotely, we encourage you to use Discord or Zoom to share screens. We're going to talk about Git a lot later today and tomorrow, but in general, it's totally fine to code separately. Especially later in the week, you're probably going to end up like taking your computer and doing some code on your own. But especially today and tomorrow, we encourage you to try to do as much as you can in this pair programming paradigm. Another set of tips and tricks that we've figured out over many years of trial and error is when we assign you a task for your breakout room, there are two things that really help you to not like panic initially when you're like, okay, I have a new thing to do and I have these 3 people to do it with. One thing to do is to assign roles for each participant, and we're going to remind you to do this. We're going to give you explicit instructions about make sure this person is the driver, this person is the navigator, etc. But if we forget, do it yourself anyway. And then the other thing is to take the first 10 or 15% of the time to think individually. So you don't need to jump into talking about it with the group right away. It's totally fine to take a little bit of time to think on your own and then go into the group discussion. And again, we're going to try to remember to tell you to do this, but also please do it yourself if we forget. All right, importantly, how do you ask questions during this workshop? We have a lot of different ways that you can ask questions. And like everything in this workshop, it's going to feel overwhelming and a lot on the first day, and then you'll sort of settle into a groove and hopefully you'll realize that it's helpful. So you can ask questions in the chat box during Zoom. We prefer that you don't unmute over Zoom. We prefer that you don't unmute. If you have a question, let us know in the chat or use the raise hand feature, and then you can unmute and ask your question. You can also just ask in the chat, and another instructor and or TAs will be monitoring the chat like Jason's doing now and answering while other people are teaching. We also have Piazza. I really like Piazza because it has an anonymous option. So you can ask a question and you can choose to be anonymous to the instructors or to your fellow classmates, to everybody. And then Piazza is also really nice because it's, I think, a little bit better organized than Discord. So it's searchable more easily, and you can just sort of scroll through all of the questions that have been asked and all the answers that we've got. We also have Discord as a sort of chat medium. So we want you to be able to communicate with your fellow participants. We want to be able to make announcements. So that's what we use Discord for. Yeah, so I encourage, if you have questions about the technical questions about stuff, I would encourage you to put that on Piazza. If you have a question about where are we going for lunch, I would put that on Discord. And TAs and instructors, as I said, will be monitoring these mediums before, during, and after lectures. So anytime you ask a question, we'll get to it. Okay, so we've, like I said, we've designed this course to take around 35 to 40 hours of your time in total, about 1 week working full time. This includes 15 to 20 hours on lessons or synchronous activities, 15 if you don't attend any of the optional lectures, and then 20 if you attend all of the optional lectures. 5 hours on individual work, so this will be finishing in-class activities, going over answer keys, etc. And then 10 hours on the group project. We're encouraging 3.3 hours per day, Monday, Tuesday, and Thursday, because remember, Wednesday is your break day. And then 5 hours on lunch breaks, resting. However, not everybody has 35 to 40 hours this week, so please discuss time expectations with your project group members. Make sure that everybody is on the same page about how much time that they want to / can spend. Also keep in mind that you're going to have these materials from this workshop forever. So if you start to feel really overwhelmed, remember that you don't have to take all of the information and plug it into your brain this week. You can come back to it later if you need to. Okay, importantly, who's in the room or the Zoom right now? There are people in this room who could teach this class. There's people who have no experience with anything we're going over. There's people in between these experience levels, people of different genders, ethnicities, races, and sexualities, people from different socioeconomic classes, people from different nations, people with disabilities, and people who are stressed about something other than the workshop. It's really important that you're all welcome here and you all belong here. Everybody also has different goals and priorities for this workshop, and everyone's going to take something different out of this workshop, and that's okay. The goal is not to teach everybody exactly the same amount of information, but for all of you to leave with more information and confidence than you came in with. So with this in mind, I want to talk a little bit about the code of conduct. I'm going to read only the second half of the code of conduct. This is the first half of the code of conduct, but it's in these slides if you want to come back to it. It's also linked in the workshop cheat sheet that's at the beginning of this presentation. So we encourage everybody to adhere to the following principles: to treat others with respect, to recognize the humanity of people with different backgrounds, life experiences, and preparation levels from themselves, to acknowledge their own contributions and agree to share their work, to recognize and celebrate the contributions of others, to create a culture of giving and receiving constructive feedback, to commit to a mission of supporting equity, diversity, and inclusion in science, and to be conscious of their contributions to group conversations. Talkative folks like me should be careful not to talk over others. We also ask you not to use curse words or make offensive jokes, even potentially offensive jokes. And we want to really thank you for helping to make this a welcoming and friendly community for all. I really love the Code Astro community, and I'm very happy to welcome all of you into the community. And just to remind you, we've got this anonymous feedback form here, so if you're concerned about anything or you feel uncomfortable at any point, please fill it out and we'll help you. We're also going to enact the following social rules. I want to go over these a little bit. I really like doing this because we're all sort of told, like, be a good person, but never really told, like, how to be a nice person, how to not be rude to other people. So I really like this, especially for, like, interacting with people when you're writing software. I really like these 4 social rules. So the social rules we're going to enact for this workshop are no well-actuallys, no feigned surprise, no backseat driving, and no subtle isms. So it's easiest to understand these with examples. So the first is no well-actuallys. So an example of a well-actually is Alice said, I just installed Linux on my computer. And Bob says it's actually called New Linux. So you're like sort of correcting some part of what that person's saying. Also no feigning surprise. So if Dan says, what's the command line? And Carol says, wait, you've never used the command line? So you're pretending to be surprised that somebody doesn't know something. So always, like, be accepting of where people are. No backseat driving. If Alice says, what's the name of the string copy function? Alice says string copy, and then Eve from across the room says, you should actually use stroll copy, it's safer. So if you weren't originally part of the conversation, it's not backseat driving is like lobbing advice from the other side of the room. And then also no subtle ism. So an example here is Carol says Windows is hard to use. Bob says, no way, Windows is so easy that even my mom can use it. So we're sort of subtly implying here that, like, moms are not going to be as good at coding, for example. So you want to be conscious of any sort of isms in these like statements that you make. And again, I encourage you to read through this. It's really short, but it's very good. One more thing is that this year, you should have, I think this morning, received an email from Vidya Venkatesan, who's giving out a pre-workshop survey. She's interested in studying how Code Astro affects people's view of themselves in coding. So we've also added some of the questions from her study to the end of workshop survey. But if you want to help us out understanding the impact of Code Astro, please also fill out the pre-survey. And this is for TAs and participants. So TAs, we encourage you to respond as well. All right, so last thing before we do our first breakout room is we want to introduce ourselves. So me, Sarah, who's been talking to you for the last however long, I am a postdoc at Santa Cruz, and starting in the fall, I'm going to be a professor at CU Boulder. And yeah, I use she, her pronouns. You guys want to introduce yourselves? And TAs, why don't you come up and make a line here?
Hi, I'm Jason Wong. I'm a professor at Northwestern University. I use he, him pronouns.
Hi, everyone. My name is Matt Hosick. I use he, him pronouns, and I'm an assistant researcher at UCLA. So great to be here and see everyone.
Yay. All right, let's see. All right, Ray.
Hi, I'm Ray.
Here, wait, Ray, do you want to be on the camera?
Come in front of the camera.
Hello, Zoom people. Hi, I'm Ray, she, her pronouns. I'm currently a postdoc at NASA Goddard. Yeah, is there anything else to say?
Great.
Oh, I'm also in charge of the Discord, so if you run into any problems of like not being able to access your group or you change groups, please get in touch with me, I'll fix it.
Thanks, Ray. Kruthi, you're online? Oh, no, she's not. Sorry. I knew that. Kruthi's not online, but she's one of our head TAs this year, and she's fantastic. She's been involved in Code Astro a lot. Sheila.
Hello, everyone, and everyone on Zoom. My name is Sheila. I just finished grad school at the University of Florida, and I'm starting a postdoc soon at Flatiron. I TA'd last year in 2025, and I'm back this year. I'm really excited to be working with all of you. Open to any questions if anyone has questions, and if I am your TA, you should have gotten a Discord message from me just now, so we'll find each other.
Hania?
Hello, everyone. I'm Hania. I just finished my third year in grad school at Ohio State. I work on multiple different things. I used to work on exoplanets. Now I do mostly galaxies and chemical evolution stuff. I was a TA last year. I'm back this year and very excited to work with everyone. And yeah, please ask me questions anytime and anything.
Hey. Chai, are you online, Chai?
Hello. Can you guys hear me?
Yep. Go for it.
Okay. Hello, guys. I'm Chai. I'm currently a research engineer at CA in Paris-Saclay. I was a participant in 2023, and I was a TA last year, and I'm back this year again. Yeah, let me know if you guys have any questions or just want to chat or something.
Awesome. Thanks, Chai. All right. Elizabeth, are you online?
Yes.
Okay.
Hello, my name is Elizabeth Moreno Hilario. I'm a remote TA this year. And yeah, I did my PhD in the Astronomy Institute in the UNAM, Mexico. And I'm really excited for this edition of Code Astro. So if you have any questions or get stuck on something, don't hesitate to reach out. Here is my contact information. And we are all here to help and make sure that you get all the most of the workshop.
Awesome. Thanks, Elizabeth. All right, Daniel.
Yeah, hi everyone. I'm Daniel. I'm a software engineer for the U.S. National Radio Astronomy Observatory. I attended Code Astro last year and really excited to be back as a TA. If you're in one of my groups, you should have gotten a Discord message from me already. Yeah, we're all here to help. Looking forward to helping you all this week.
Gopika?
Hi everyone, I'm Gopika. I'm finishing up my second year as a grad student in Purdue, and this is my first time as a TA. So let me know if you guys have any feedback by the end of the week. And also I work like mainly on protoplanetary disks, but like I'm so interested in hydrodynamics in general. And yeah, that's all.
All right, David, I think is not in this time zone, but he's coordinating the Manchester hub this year. So in case you didn't know, folks on Zoom and folks in person, we have 3 local hubs around the world. So one in the UK, one in Hawaii, and then one in Bangalore. So those folks will be also participating just from a different location. Lauren?
Yeah, hi everyone. Really excited to be here. My name's Lauren. I use he, him pronouns, and I'm a 4th-year grad student at the University of Wisconsin-Madison. So I was a participant last year, and I'm excited to be TAing remotely this year. I'll also be Zoom liaisoning during the workshop this week. So if you have questions, you can type them in the chat. I'll be the first one to look at that. I'll try to answer them myself, and if I can't, I'll poke Jenna, who will introduce herself shortly, and we'll make sure we'll get your questions answered, and hopefully you can get the most out of this workshop with us. So yeah, thanks.
Thanks, Lauren. All right, Evan is coordinating the Hawaii local hub. And then Sonith is coordinating the Bangalore local hub. All right, did we get everybody? Oh, Jenna. Jenna, did I skip you?
That's okay. I can just, as well.
Yeah, come introduce yourself.
And a nice little photo of me on the beach, but you guys don't get to see
Sorry.
it. You saw it, yay. But hi, everyone. My name is Jenna Karcheski. I'm a first-year grad student here at UCSC. Shout out UCSC local people.
Go Slugs.
But also shout out the UW people. It's great to see some people both on Zoom and in the room today. I just finished up my undergrad there last year in comp sci, data science, and astronomy. And it is my first time TAing for Code Astro, having taken the course last year. I loved it so much that I'm back now as a TA, and I'm excited to meet and work with you all this week. So,
Yay. Woo. All right, thanks TAs and instructors. Yay. All right, so we're now going to do a 5-minute, our first breakout. So as a reminder, we're going to encourage you, at least at first, to do this with your project groups. Before we take a brief break, I want to share with you the goals of today's activities. So at the end of today, you're going to be able to identify which development environment is most appropriate for your programming task, decide when and how to design software using functional and object-oriented paradigms, use Git to contribute version-controlled code, and depending on timing, either today or tomorrow, define Git flow and give examples of the advantages of Git flow. For the project, your project goal for today is to decide the purpose of the package and to write one central function or class and put it on GitHub. So an example, say me and my partner are working on a package that plots the most likely galactic orbits for a user-specified subset of the Gaia catalog. Today, me and my partner will write a function that uses galpy to compute and plot orbits for a list of stars, and other partners will write a class for constructing the list of stars using user input. They'll use 2 separate Git branches to do this, and we're going to talk to you about Git branches in a sec. I also want to go over 2 different ways of saving your changes to the Code Astro repository. So as part of the setup, you should have cloned the Git repository where Code Astro lives. So if you want to make changes, you can first, you have an option to save changes only on your computer. So you won't be able to access them from GitHub, but they'll live on your computer. The way to do this is first from the command line, you change directory into where you put Code Astro. You then type git stash, then git pull, git pull is going to take the changes from GitHub and pull them onto your local computer. And then to apply the changes that you made, you do git stash pop. So basically, this git stash is like, take the changes that I made and just hold them for a second. Git pull takes all the changes that like me and Jason and Matt made, pulls them down to your main computer, and then git stash pop will reapply your changes. And you can ask your TAs if you run into any issues with this. So this is option 1, saving changes only on your computer. Another option is to save changes in your own copy of the Code Astro repository on GitHub. So basically you make it available in the cloud. The way that you do this is the first step is to make a fork. So if you go to the Code Astro GitHub repository, there's this fork button in the top right corner. So you click on that. And then you want to then change the version of Code Astro that you've cloned onto your computer to link or sync to this fork. So the way you do this is first you change directory into the Code Astro directory, and then you run these 3 commands. You're going to remove the upstream, then add an upstream and add an origin. So setting upstream basically means this is where I'm going to pull in new changes from, and then origin means this is where I'm going to push new changes to. So you'll pull new changes from our version of the repository, and then you'll take your changes and push them onto your version of the repository. And remember, these slides are available if you just Google Code Astro GitHub. They'll be on the first day's README, linked from the first day's README. So you can also take your time to go through these instructions. All right, let's take a 5-minute break, and then we're going to get started with content. So that'll be at 9:56.
All right. Yeah, so we're going to talk today about development environments. As you saw from the installation, we asked you to install VS Code if you haven't done it already. VS Code is what's called an integrated development environment or an IDE. IDEs are nice because they're kind of these all-in-one applications that come with many features to help you code. They do have a little bit of a learning curve, but we think it's worth the small amount of effort, and that's why we would encourage you, if you haven't used VS Code or any other IDE before, to spend this week and try to use it and learn it, basically, because we think there's a lot of features there that could help you code in the future. Two of the leading IDEs for Python are VS Code and PyCharm. I think that's maybe still true. So we're going to show you, we'll be demoing some features of VS Code throughout the week. Sarah did a nice intro video in the day 0 installation showing you some of the basics of VS Code, but I'm going to go through it very quickly right now. So here's my VS Code editor. The nice thing about these IDEs, usually these IDEs are all set up like this. You have some sort of, you open up some folder that corresponds to your coding project. So I've opened up the Code Astro folder. You can see this is like day 0, day 1, day 2, day 3. All the folders are here. And you can see all the stuff inside each of the folders. You can open up a file and it'll open up here and you can start typing things like this. And usually there's a bunch of terminals down at the bottom which lets you run things. There's like a regular terminal, and then there'll be also things like debug console and output. And we'll be talking a lot more about debugging tomorrow and how to use the debug features in VS Code, which I think is probably one of the most powerful things. One of the big differences between an IDE and like a regular text editor like Vim or Emacs or Atom or Sublime Text and things like that. Another nice thing about these IDEs is, again, these are things that sometimes is a little bit annoying to set up in the very beginning, but we think it's worth it, is you can hook it up to your Python installation. So I've hooked it up here in the bottom right corner to my Code Astro Conda installation. So I'm basically, when I open up the Code Astro folder, it knows that I should always be using the Code Astro Conda Python install, basically. Now, make the font even bigger. How's that? 1 or 2? Okay, 2, right. Okay, good. So once I've hooked it up to the Code Astro Python environment, which I guess you'll practice tomorrow probably at the latest. I can do things like array equals to numpy dot something, and it will start giving me suggestions for what kind of functions I should have. And I can do something like this. I want an array. And it also comes with kind of what's called linting. Linting is basically like spell check for programming. So like if I misspell a word, you'll see like a misspell on a variable, you'll see that it creates this little squiggly line, just like how you would in a text editor, being like, hey, this thing's not defined. You have some sort of typing error here. So these are some of the nice features that come along with helping you code, and using it will help you kind of mitigate the number of bugs that happen as you are coding. Yes, debug mode is probably one of the most powerful features of IDEs, and we'll be demoing that tomorrow, and showing you why this basically saves me so much time in debugging. But it's a little bit of a pain to set up, but that's why we're gonna go through that pain tomorrow together, and hopefully you'll find it to be useful. And there's also integration with other things. You can install VS Code extensions, and different extensions let you do different things. There's a Git integration that lets you integrate with source control and things like that. There are other integrations that we aren't going to demo here, but we've provided resources for, where you can search for them online. Things like SSH integrations is probably one of my favorite features of VS Code, is being able to, any machine you can SSH remotely access, you can open up a VS Code on your laptop as if you're SSH into that machine, and basically type and edit code on that and run and debug code on that machine as if you were on that machine, but on your laptop. There's yes, and we provided a link to instructions there. So if you work over SSH and you've never done this before, I encourage you to check it out. It was game changing for me. All right, so that's one kind of environment, which is IDEs. Another one are these Jupyter notebooks. A lot of the things we are teaching you today in Code Astro will be in the form of Jupyter notebooks. Jupyter notebooks are nice. They're a combination of code cells, so actual code cells, and markdown cells, these text cells like you see here. They're very useful for things like writing tutorials, so basically like, writing text and having diagrams and then having pieces of code alongside of that. It's also good for kind of playing around with things, running and rerunning one cell at a time allows you kind of play around with the code, understand how it works. It's useful for things like plotting, solving a problem, because you can think of it like a document. You basically are producing a document that shows how you produce that plot in the end. There are some caveats with Jupyter notebooks. You should, we don't recommend you to code exclusively in Jupyter notebooks. One of the things is that the output depends on the order that cells are run or rerun. So just for example, I have to start a session. Let's see if this works. So I give you I equals to 1, run anyways. And then I do another plus equal to 1 like that. And then I do another cell that's print I, right? So this will print out 2 right now, but if I decide to run this cell 3 times, then I run this cell once, then I run this cell another 4 times, like what is the output of this third cell? It's it depends on the order of which I just, clicked a bunch of things. And that's not very good for reproducibility. It's actually hard for debugging sometimes, especially when you're running very complicated code. You're like, oh, I have to run cells 1, 2, 4, and then 3, and then 5, and then 10, and then back to 4. So this is not really good for reproducibility. So it's good for playing around with, but you don't want to always do everything through this. And it's not also designed to program a software package, which usually requires multiple files, many things talking to one another, whereas here you just get one notebook. So it's good for some things, but not as good for developing an open source package, is what we're asking you to do in this workshop. So that's why we're recommending you to do stuff in VS Code. And then there's also the plain text editors. These are kind of some of your, I mentioned your old school editors. We generally recommend against doing large amounts of programming in them. As I find now, at least, I write code with a lot more bugs when I use them. And one of the main reasons people in the past use these plain text editors is because they had to SSH into a machine and edit scripts on that machine and run them. But now you can use VS Code over SSH, so we recommend to do that basically whenever possible. Also, we're now in this workshop's been around for 7 years, and every year we've been evolving coding technology is evolving quite rapidly. Generative AI has launched in the middle of Code Astro, so we've kind of had to adapt things for that. But not a lot. Both VS Code and Google Colab come with AI tools. You might have saw that when I was demoing the Colab. It was like, do you want to generate code here? Basically, since all of our answer keys are flowing in the internet and now generated AI models are pretty good at solving some programming problems, they basically know the answers to all of our activities. So we're basically, for the purpose of learning, it's not about getting the right answers, it's about you guys understanding how to do this. So we're asking you to turn off these AI tools for the purposes of the Code Astro lessons, because otherwise Colab will just give you the answer without you even looking. I've tested this. So how to turn off? So in Google Colab, AI autocomplete is oftentimes on by default. To turn it off, you got to go to the settings bar over in the top right corner. You go to AI assistance, and then you have to turn off show AI powered inline completions. As long as you turn this off, it should not auto-complete and prompt the solution for you, because we'll be giving you code blocks and asking you to kind of work through them yourself. And the goal is to work through them yourself so you understand, conceptually what this is doing. And then, that way, you can build your own understanding of these things. In VS Code, GitHub Copilot is disabled by default, but if you've enabled it, you can turn it off by clicking on the Copilot logo in the bottom right corner, or clicking on the settings button down there. So I'm not going to demo that because I didn't practice that, and that means that it's probably going to go wrong if I try to demo that right now. we're not, and then we'll have an optional lesson later today about vibe coding and our thoughts about vibe coding. But for the purposes of the in-class materials and the lessons, we're asking you to turn this off because otherwise, I don't think you'll learn anything. Basically, you'll just see the answer immediately. Okay. So that's everything on kind of development environments. Everyone will kind of develop their own preferences and styles, and we're just asking you all to give VS Code and IDEs a try if you haven't given it a try before this week. Okay, so we're now going to move on to our kind of first, our next lesson, which is talking about some programming paradigms. We're not going to talk about everything in software development. There's way too many things to talk about, but we're going to focus on kind of one thing, which is like a structural thing about how you structure code. And this is object-oriented and functional programming. So here's our first meme of the workshop. So this is our memes are now vintage because they were made in 2020.
We have some new ones.
We have some new ones, but a lot of them are vintage memes now.
Open issue to update the memes.
Yes, so you might have heard about object-oriented programming. You might have heard people be like, "Oh yeah, we should write this in object-oriented programming." So like, what is object-oriented programming? Why do people like it so much? So object-oriented programming is centered around classes. That's kind of the object-orientedness. Object-oriented means like we've centered our programming around classes. We structured our code around this concept of classes. Classes organize variables and functions into a single object. So for example, let's say we're making a class that controls or monitors the state of a telescope. That telescope class could have functions like telescope.closeShutter. So that's a variable that belongs to the class. And it can also have attributes like telescope.current target. It's like the current star that we're looking at with the telescope. Objects can be useful to track state, which is very useful for modeling many things in our world because the things in our world kind of have some inherent properties and they change with time. So for example, telescope that current target will change every time we move our telescope to look at a new star. That's something that's nice about this object-oriented design that we have here. Classes can also have inheritance. Inheritance means that it can take fields or functions from a superclass or a parent class. That's kind of programming lingo for kind of a class that it inherits properties from. It is useful for reorganizing or reusing code. So say we have this telescope class that has things like closed shutter and current target, but then we can also create a subclass that's called the space telescope class. The space telescope is a subclass of the telescope class. It also has the closed shutter and current target attributes, but it might also have specific functionality that doesn't apply to all telescopes, such as an attribute that's distance to Earth, right? For most telescopes, we don't really care about the distance to Earth, but for the space telescope, we might care about the distance to Earth. Our diagnostic notebook has some basics on the syntax of these things, but this is just getting you thinking about, this is how this is kind of the purpose of object-oriented programming is to kind of center things around classes, center things around the state of classes. So like state changes, lots of things in our state and states of particles, states in physics change. So we are using that to using the classes to track the changes of the state and using that dynamically to basically structure our code. So I think we can keep rambling more on and on, but I feel like the best way to kind of do this is kind of just to do some object-oriented programming. So this is going to be your first breakout group activity. So your activity is to build. We're going to go through this kind of painfully line by line, just because it's the first one, and within the future you won't do this. But your goal is to build a gravity simulator. So you've seen like 16 code text blocks of Markdown in this notebook, but here's your first coding block. So we've built this this free fall gravity simulator in this object-oriented paradigm kind of structure already, but it's up to you to kind of fill out the rest. So there's a particle superclass. So this is just a particle that can move in 3D. Currently has nothing in it, but it exists. And then we have this subclass of particle, which is called free fall particle, which is a class to simulate a particle falling due to Earth's gravity starting from a stationary velocity. This free fall particle has a few methods. One is this method called underscore underscore init underscore underscore. This is the method that always gets called when you create a new instance of that class. So here below this, we have an example of how you could call this free fall particle. So you call free fall particle parentheses 10. This will basically call the init method with the first argument equal to 10. So we'll set height equal to 10. So we're going to drop this ball from a height of 10 meters. And you can see that this init class does some things. You can go through during the breakout groups and read through what it does in detail. It does, I'll just say it does essentially two things. One is that it initializes its parent class. This is always the first thing you generally do when you create a class, is that if it inherits from a superclass, you first initialize the superclass. So this initiates from the particle class, so we first initialize the particle superclass. That init function does nothing, so it doesn't really do anything, but we generally always do this. And then we initialize some attributes or other properties of this particle class that we've chosen to initialize here. You can see what these various things are. This particle class can also have some helper functions. So this is one of the these things about object-oriented programming, is that you can have you can have functions that rely on attributes. So here you have the get num steps run function, or parenthesis, which is just a function. And in Python, the first argument for any function that belongs to a class is the self argument. So a self just points to itself. So everything self means like I'm referencing the attributes of myself. And the nice thing about object-oriented programming is that you can, have these things like get num steps run, and this was basically a function that returns a number of timestamps that have run, basically by comparing the current elapsed time in the simulation, self.time, with the time step of the simulation, self.dt, or delta time. And basically this divides self.time by self.delta time to get the number of steps run. And how this would look is get num steps run like this. So like if you were to call it in the code, it would just look like this, right? It would just look like self ball.get num steps run, and implicitly, because you did ball dot, that ball gets passed in implicitly as that first argument, also known as self, in this object-oriented programming paradigm. So there's that, and then your activity will be to write the simulate time step function, which will basically advance the simulation by one timestamp. So we start at time goes 0, the delta time, the dt, the time step in the simulation is 0.1 seconds. You need to advance the simulation by 0.1 seconds. The ball has changed in velocity, the position has maybe changed, things like that. So then you advance it by another timestamp, the ball has changed in velocity again, position maybe has changed again. So you're basically writing a little mini simulator. Right now, the simulate timestamp does nothing. So if I run this code, it creates a free fall particle at a height of 10 meters and calls simulate timestamp twice. Oops, I forgot to run this code. Okay. You'll see that, it's printing out the time and the height, and it always prints out the time as t goes 0 and the height is 10 meters because nothing has happened this whole time. Okay, so your goal is to make this simulator work, you basically just need to modify code in this simulate time step function. If you finish ahead of time, you can try to think about how to restructure the code so that there's things in the particle superclass and then there's freefall particle subclass. Think about how you would more generalize this freefall simulator into maybe simulators for other physics as well. And at the end of this, when you're done, reply to a Piazza post. There's a Piazza post posted about your result for how long it takes for the particle to fall to the ground from a height of 10 meters. So you can obviously compute this analytically on pen and paper. We're not asking you to do that. We're just asking you to use the simulator to answer this question. So as Sarah said, your roles are going to be, break out into your groups. There's going to be one driver who's in charge of sharing their screen and typing the code for the activity. But they're just in charge, and that person is the person that lives at the highest latitude. And they're just in charge of typing code. And this driver should, tell other people, the other people should be telling them what to type. So those were the navigators are in charge of doing. So they're in charge of doing the higher level kind of structuring of the code and thinking about, what are the next steps to do. And like Sarah said, maybe if you want to spend the first 10% of the activity just thinking about it individually on your own, reading through all the stuff I just showed you here before diving in. There's some instructions, figure out your roles, read and discuss, and do this, code it up and get an answer and post your answer on Piazza. Okay, let's come back together. I saw we have some good answers here, so let's take a look. So how long does it take for a particle to drop from a height of 10 meters in Earth's gravity? And we got 1.43, 1.43, 1.4, 1.4, 1.43, 0.4. Very good. We got lots of good answers. I believe the analytical answer, assuming exactly 9.8 meters per second for the Earth's gravity, is 1.429 seconds. So we did pretty good with our free fall gravity simulator. Um, um, so Right. So hopefully so we'll post the solutions to the free fall gravity simulator on Discord later, so you can take a look at the solutions and how it was implemented. If you didn't have a chance to find a good implementation. I just want now that you've done some object-oriented programming, I wanted to kind of summarize and highlight some of the kind of characteristics of object-oriented programming now that you kind of experienced it. You see that a lot of your coding in object-oriented programming is structured around objects. So you built these objects kind of from the very get-go, and then figure out how do you make these objects do the thing that you want it to do. The code that you wrote depended on the changing or mutable, that's a programming term. Mutable means changeable state of the object. So you probably use variables like self.height and self.velocity, and then those variables change throughout as you wrote them. As you worked with them, every time you call simulate time step, those variables change because the state of the world is changing. Lots of things in the world change, so it makes oftentimes it makes sense to frame things this way. And generally, when you are approaching a program problem, we recommend trying to identify entities that should become objects and program around this. So, like, if you're making a simulation and you have particles in the simulation, all these particles are kind of the same as each other, but they have different, exact properties. But the properties they have are the same. That's a good way. That's a good thing to put into a class. To be able to structure that. Same thing if you're writing some sort of data reduction pipeline to produce a spectrum file from a pipeline, all those spectrum files may have different data values, but they all have the same format. Again, this is a good place to, make an object or a class that kind of structures how that format and those attributes look like. There are some subtleties and issues with object-oriented programming. One is that creating an object can be slow. So actually creating an object, if you look at the underlying number of function calls that happen underneath the hood for Python, there's a lot of them. So if you're making tens of thousands or hundreds of thousands of objects, you'll notice a slowdown in your code. So don't make everything an object. Every time you're making a new number, don't make it an object, right? It's just gonna slow down your code by having to make objects over and over and over and over again. One of the other kind of caveats to object-oriented programming is inherent to object-oriented programming is that object-oriented programming can be more prone to bugs because an output of a function depends both on the inputs of the function and the current state of the object, which is implicit. So like you could have a function that has some arguments, and that function takes those arguments and takes the current state of the object to produce some output. So that's two inputs, one of which is not like clearly documented when you're calling that function. It's implicit in the state of the variable that you're using that creates the output. So because of this, sometimes it's harder to debug object-oriented programming code because you're like, I'm calling this function and passing this argument. Why is it producing this? It's because, oh, there's this other secret setting or secret attribute that's being used in this function that causes something to change. So that's kind of a caveat or a gotcha of object-oriented programming. So there's times in which you maybe don't want to use object-oriented programming as well. If you're interested in learning more, there's we linked to a few links. One is a more conceptual discussion of object-oriented programming, and one's a more technical, like here are features of Python related to object-oriented programming if you're interested. We'll also briefly talk about functional programming. So let's this is our second vintage meme of the class. This is really unfair to functional programming because functional programming is actually really really quite useful in many ways, especially in scientific computing. Functional programming, the key paradigm of functional programming is that the function outputs solely depends on the inputs. This is quite different from object-oriented programming where you say the function outputs depends on both the function inputs and the state of your objects, right? Here in functional programming, any function should depend solely on the inputs of that function. This is useful in that it's easier to guarantee correctness, but it comes with the con that it's messier to keep track of the changing state of things. You don't want having changing state. So we'll see in a second for the free fall gravity simulator, we'll re-implement it in a functional programming paradigm. You'll see that it's a bit trickier to keep track of the changing state of things because of that. One kind of misbelief is that functional programming is not the same as not using classes. You can still have classes in functional programming. Those classes are generally static and immutable. So immutable is not changing, instead of compared to mutable. So usually if you want to change the state of something, you generally have to create a new object if you want to follow a functional programming paradigm rather than changing the attributes of that object, which is an object-oriented programming paradigm. There are maybe some of you use like AstroPy and I use AstroPy units. AstroPy units is a good example of functional programming, but that uses classes. You have classes like your units class, and you can do u.meters to u.nanometers. So these are two objects, u.meters and u.nanometers, but these are immutable. These never change. And this function will always produce the same answer because it's immutable. So this is an example of kind of functional programming. It's really functional programming, but it's using objects to do functional programming. This could be useful in astronomy. Sometimes we are implementing physics equations. Maybe if you're implementing a data pipeline where given some input, you should always produce the same output. So again, maybe a place where you want to implement some sort of functional programming paradigm to ensure that repeatability. So object-oriented programming is useful when things change, or functional programming is good for deterministic things. And one thing is that this competition between the two is kind of a false competition. Basically, most modern software packages use both paradigms. So it's not like you have to do only object-oriented or only do functional. We're just giving you these two as kind of like design ideas, and you can mix and match them and integrate both of them into your package or code that you write. We're just asking you to be more conscious and about what you're doing when you're doing it, basically. When you're writing function, when you're writing classes, how you're structuring that code. In the end, both of these paradigms are kind of programming styles to solve an engineering problem, and each group development team will have their different approaches to tackling the problems, and you can have an object-oriented approach and a pure functional approach to tackle the same problem. And as long it solves the problem and keeps the code maintainable, then it's a good solution, right? It's just an engineering solution. There's no one correct, elegant answer, right? It's these are all practical ways to solve a problem and based on the engineering constraints that we have. So just in the last few minutes, I wanted to show you a little bit of a taste of functional programming. So here is the free fall simulator that you guys just been spending time thinking about, written in a functional programming example. So here we have another particle class. This class you can initialize as well with a height and a velocity. So this is basically tracking an instantaneous state of the particle. So what is the current state of what is the state of the particle at a given height and velocity? It's like a snapshot. And here we've written a function called free fall time step, which is to simulate the free fall of a particle for a small time step. And what this function does is that given an input of a function of a particle at a given height and a velocity and an input time step, it produces a new particle that represents the new state of the particle at the next time step. So we're not changing the attributes of the initial input particle. We're creating a new particle to represent the new state. So you can see how this could be clunky, but how this could maybe be useful. Let's see, we can run this code first. Okay, so here, we can create a particle, and we attach it to a list that tracks all the previous history, the states of the particle in time, and for every time step t, we can call the free fall time step function, which given a state of a particle, it produces the next state of the particle in the simulation, and then we add that next state of the particle in the simulation into our list of states. We have like a whole list of like snapshots of where the ball is and how fast it's dropping as a function over time in our simulation. So we have this, instead of a single particle now, we have a whole list, which takes up maybe more memory, but we have a whole list of all these particle states. And then another nice thing another thing about functional programming is that if you call free fall time step twice on the same input particle and you look at the output particle it produces, you'll see that they give you the same height. So basically, the same inputs always give you the same outputs. This could be a good thing, could be a misleading thing. So it depends on the programming context and what you're trying to do, whether that's useful or not. Okay, I think this is the end of this. If you're more interested, we have another bonus activity if you kind of get more you can do in your free time to get more interested to get more into object-oriented and functional programming. But this is just to get you thinking about how you design your code and how you use classes and functions are kind of the core things that make up most of the packages that you probably interact with. Okay, so we'll end that here. Let's take a 10-minute break, and then we'll resume at the top of the next hour for Git and GitHub Basics. Okay, so 10-minute break.
So we're going to get started on our next lesson here. Okay, so what is Git? Well, Git is a type of version control. And what version control is that's just a protocol for tracking changes in files. Source control, version control, those are both the same things. So there are many different types of version control out there, but we're going to talk about Git because it's by far one of the most popular protocols in both academia and industry. And as I'll give everyone a moment to appreciate our vintage meme, of course, because Git is so popular, that means it's clear and easy to use, right? Right, well... Okay, so Git, admittedly, there's a little bit of a learning curve to start using it, but it's really powerful. And one of the goals of this workshop is to get everyone comfortable with the basics of Git so you can use it in your own work. So we'll work through this together. Okay. So why should we use version control at all? Well, there's a bunch of different reasons why we'd want to do this. One is to keep track of legacy versions of your code. You can think about this in academia, right? We write a code to produce some result that we publish in a paper, right? We want to freeze that version of the code so we can always reproduce that result in the future. Well, source control gives us an easy way to save those future versions, those versions for the future. Kind of in a similar way, let's say you have this code and it's working, and then you have a great idea. You say, I want to put in this new feature. You put in that new feature and everything breaks. Well, if you want to go back to the code that was working before, rather than painstakingly undoing all of your changes line by line, with source control or version control, you can just jump back to the previous version that worked. You can also use it for debugging. You have a code, you made some changes, now the code doesn't work anymore. Well, with version control and in Git, there's a lot of nice tools that you can use to see line by line, okay, what changed in my code now versus what I had before. That can give you a hint as to what's going on. Why is the code crashing now? And then finally, and this is what most people think of when they think of using Git or version control, it's very powerful when doing collaborative work, like we'll be doing here in this workshop, right? You have version control allows multiple people to work on the same code base, make changes to the same code files, and gives us a way to keep track of the changes that are being made and to prevent people from overwriting each other's changes. Right. So our recommendation to everyone is to use source control anytime you code, not just when you code in a group. And in fact, you don't even have to be doing a coding task. You can use version control for all sorts of things. So for example, when I kind of write papers, I use Git to keep track of my paper versions. If any of you are familiar with Overleaf, right, nice online editor for LaTeX and papers, Overleaf has a nice integration with Git. So yeah, not just code, you can use Git and version control for all sorts of tasks. Okay, so with that, we're going to jump into a demo. And so in this demo, we're going to go over how to make a Git repository in GitHub and then copy it to your local machine. Okay, just defining some terms here. When I say Git repository, a Git repository, it's just a directory with files that are being tracked in Git. So Git repository, or repo for short, just think directory where Git is tracking stuff. Right? GitHub, we've talked about it a little bit already, but GitHub, this is a cloud-based platform where developers can share and save their Git repositories to. Right? So Git and GitHub are two different things. GitHub is this cloud repository where we can store Git repos. And then copy it to your local machine. Anytime I say local machine, this is your personal laptops. Okay, so then we're going to talk about how you can add and edit files into your Git repo, right, your repository. And then finally, we'll talk about how you can resolve conflicts between the remote version of your code, that's going to be the code up on GitHub, and the local version of your files. Resolving conflicts are sometimes the most trickiest things to do when dealing with Git. Okay, so this demo, we're going to kind of structure it as a code along. So feel free to code along with us, but I encourage you at some point, if you get stuck, don't try to debug on the fly. It's okay. Just, you kind of watch the rest of the demo and try to pay attention and kind of get the overall idea. We're going to have time at the end of this demo for everyone to break up in groups and work through the demo and debug any issues that come up. Okay. So with that, let's hop right into the demo. I'm going to escape this PowerPoint presentation here. Okay, so for this demo, you want to have two windows open. The first window you want to have open is a web browser. And the demo that we're going to do is on the Code Astro GitHub page. So we're at, right, here's Code Astro GitHub. If you go down to day 1, right, click that, you see there's a folder called Git Intro. We're going to click that Git Intro, and then inside this file, this folder, you see this file gitdemo.md. Right? And if you click that, this is going over the entire demo, right? So again, if you get stuck, don't worry about it. You can always refer to this demo in the future to figure things out. Okay, so we have the demo over here. The other thing you want to have open is a VS Code window, right? Because VS Code, this is where we're going to do the demo itself. We're going to do this Git on the command line just for teaching purposes. So once you have your VS Code window open, you want to have a terminal window available. It looks like this down here. Just in case you don't see a terminal window, you can always open one. A VS Code, if you go to this terminal button at the top, you go terminal, new terminal, right, this option here, and it'll open up the terminal on the bottom. Right? Okay, so these are the two windows that we want. So let's start with the web browser for now. So before we get into the demo proper, there are first some environment variables that we want to set on our machine for Git. And if you haven't used Git before, maybe these variables aren't set. So we're just going to set them really quick now before we dive in. And that's in this before starting section. And these lines here, we can just copy it. So let's start with this first line. We have git config -- global. That's this global variable, pull.rebase false. You don't have to modify this line at all. Just copy, paste it into your terminal window, and then you can hit enter. We're going to talk more about what that means later on in the workshop, so just don't worry about that for now. Okay, we also, the second line here, we want to set the username variable correctly. So again, you can copy it from the demo. Let's paste it into our terminal window, and instead of your full name, let's go ahead and you can put in your full name here, just like that. And then finally, the last thing we want to do, we want to set up the user email correctly. Same thing, copy into the terminal, and then go ahead and put in your email, right? Okay. So first, before I move on in the demo, can everyone see, is this large enough? Can folks see this terminal window here and see the text? Yes. Excellent. If it's ever too small, let me know. We'll make it bigger. Okay, great. So now let's dive in. Now we're all set. So the first thing we're going to do is we're going to make a repository on our GitHub pages, right? So let's go ahead, let's open that web browser. Let's open a new tab and go ahead and go to github.com, right? Into your account, right? We should all have accounts here. Once you get to GitHub, you can go ahead and click on your profile, which is in your upper right-hand corner. Right, you get a drop-down menu like this, and then just go down to the repositories tag, and click that, right? This is where we're going to start. Okay, so let's go ahead. Let's make a GitHub repo on our account. And the way you do that, on this screen, if we go to the upper right-hand corner, you see this green button that says New. Go ahead and click that button. And then GitHub says, okay, we're going to make a new repository. You have to, we have to fill out some information. The first thing we need to do is we need to give the repository a name. Now, GitHub is clever. It's going to give you recommendations for different names. Scaling couscous. That's interesting. I'm a lot less creative than that. So I'm just going to name my repository test git, but feel free to go wild, call it whatever you want. Description, I always find it's nice to put a little description in your demo, in your repos, what this is about. So this is test demo for Git. Just my little description there. Right. And now we have to select some configurations. The first thing that's very important is we want to choose the visibility of our GitHub repository. By default, it's public. And for this demo, we're going to go ahead and keep our repos public. What that means is that anyone on GitHub can Google search, can search in GitHub and find your repository. But you could imagine, let's say you're working with collaborators and you're working, with code you're not ready to share yet. You can make repositories private, and so that it's only shared among people who actively get invited to it. Okay, for now, we're going to keep our visibility as public. And then the last thing here, let's go ahead and toggle this switch that says add README. Yeah, READMEs are just nice to have. And let's not worry about git ignore or add license for now. These are things we're going to talk about later in the workshop. Okay, so now once we have that, we can go ahead and press this green button at the bottom to create the repository. Okay. And then GitHub does its thing. And here we go. We now have a new page on our GitHub account with our test git repository here. Awesome. Okay, so this is well and good, but now let's take this repo that we've created on GitHub and let's copy it down to our local laptops, right? Now in Git vernacular, that means we want to clone this repository. So how do we do that? Well, first, let's go ahead over to our VS Code window. We have our terminal. And the first thing we need to do is we need to choose a place on our laptop where we want to clone this repository to. You don't... it doesn't matter where on your machine that you copy this repository to. You just don't want to copy it inside of another Git repository, because then that could get complicated. So don't clone this thing inside the code Astro Git repo, for example. Just, you can place this somewhere else on your machine. Okay, so I've made this little test directory that we're going to copy it to. Okay, so how do you clone this repository? If we go to the web page, you can click this green button that says code, right? And you have this drop down here and you have an HTTPS address, right? Go ahead and copy this address, put that button there. And then we can go into VS Code, right? We're in the terminal, we're where we want to copy the repository to, and we're gonna use the command git clone, and then we can go ahead and paste that URL that we copied. Go ahead. Git does its thing. And now, right, if I do an ls in this empty directory I had before, now we see that test git exists. It's now on my local machine. And I'm going to go ahead and just cd into test git for now. Okay, great. Okay, so now we have the repo on our local machine. I'm going to share one of my favorite Git commands of all time, and that is the command git status. I will use this all the time throughout the demo. And this just tells you the status of your repository. Okay, so I do git status now. It's just, it gives us some information. It says, okay, well, our repo, we're on branch main. We're going to talk about branches in a little bit. Don't worry about that for now. We'll stick with the main branch. The branch is up to date with the origin. Fine. I should say now, what we mean by origin, that repository that we made up on GitHub, that's considered the origin of the repository. And then now we have a copy of the origin, like we have the local version of the repository on our machine. So origin, think GitHub, and then we have our local copy on the machine. Okay, so not much there. Great. Okay, so let's go ahead, let's add a file to this Git repository, right? And let's do it on our local machine in VS Code. And so there's a couple different ways you can do this. But here, I'm just going to go into VS Code and go File, Open Folder. And I'm going to open that Git repository that we just made. So for me, it's desktop, and then I have test here, test. And I'm going to just go ahead and open test Git. And now when I do that, I see in this kind of Explorer window here, I see the test Git directory exists. There. Okay. How do we add a file in VS Code to a folder? Well, we can use this button in test Git here. It's got a big plus sign and it says new file. I'm going to click that and I have this thing. Let's make a new file called hello.txt. Right? And just like that, you see kind of hello.txt opens here. Now, I will point out sometimes as you're doing all of this, move that away, the terminal window disappeared. Don't worry about it. Again, you can always get the terminal window again by going to Terminal, New Terminal, and here the terminal will restart again in this corner. And we want to be inside the terminal. We want to be inside this test Git. Okay. Okay, so we've made hello.txt. Let's go ahead and just add a little line of text here on the first. Okay, I'm just going to add some text there. Okay, now let's go ahead and let's run our git status command again. And if we do that, we see now that, I'm going to make this a little bigger to make it easier to see. We see that our output from git status has changed. Now, Git recognizes, it says, aha, there's this new file, hello.txt in this directory, right? But Git isn't tracking this file yet. It's untracked. We need to tell Git, yes, I want to add this file to the repository. I want you to track it. How do we do that? Well, we use a command called git add, and then you can go ahead and type in the name, of the file. So git add hello.txt, right? Just like that. Okay, let's run git status again. As I warned you, it's my favorite command. And now we see that the status has changed again. Now it says, aha, now I see that there is this new file that I'm supposed to be tracking, and there are changes, and this file has changed. Okay, so now Git knows we need to track it. Now we need to tell Git, yes, the changes that we've made in this file, I want you to save into the Git history. These are changes that I do want to track, right? These are changes that I want to commit to the repository. And that's exactly what we're going to do. We're going to, in order to commit these changes, we will use a command called git commit. And the full command, you git commit, name of the file, hello.txt. And we don't stop there. There's one more thing we need to do. We need to add a commit message, right? Which is a short little string saying what changes were implemented in this change. So the way you do that, you add a -m, and then in quotes, we can put our git commit message. Now, I encourage you, git commit messages, you want them to be short, but you do want them to be meaningful. You could imagine if you're working on this big repository and there are hundreds of commits that you're trying to debug, sorting through these commit messages can be very helpful as long as you have helpful messages. So for this message, let's just go ahead and say, okay, this is the first commit of this file. So now I have git commit hello.txt -m commit message, and then I can go ahead and add it. Okay, now one more time, let's go ahead and do git status. Now the status has changed. Right now, the repo recognizes, okay, we're on Git, we're still on the main branch, that's fine. But now you can see the output says the branch is ahead of the origin, right? This thing up on the repo by 1 commit. That's the commit we just added. So let's do the final step, right? Now we've changed the repository on our local machine. Now let's go ahead and push those changes up to the origin on GitHub. And I use the word push because that's the name of the git command. in order to do this, we say git push. We specify we're going to go to the origin, right? We're going to go up to GitHub. And let's also specify which branch we're pushing to, main, right? So the full command is git push origin main, right? We do that, and Git does its thing. Okay, so let's hop over to our repository on the website here, right? Here's our test Git repo. Now, if we refresh this page, there we go. There is hello.txt. That's what we just made on our local machine. Now it lives in the origin, now the repo on GitHub. Okay, let's go back to VS Code. Now let's make another change to this file. We have hello.txt just in the text editor here. Let's add a second line of text. All right, we're going to save it. Okay, right now, if we run our git status, it says, aha, this file has been modified. Now, I want to pause here because sometimes when you're working in a code repo, at least for me, I get this message that a file has been modified, but I forget what that modification was, right? What has changed? So a useful command I find is called git diff. You can do git diff and then put the name of your file here. And you're going to get a little bit of text output that's going to tell you what has changed in the file. Here it says, oh, okay, before the text was first, now we have first and second. Okay, so I find git that to be useful. Yeah, because now I can write a commit message. Now I know, is this something I want to keep? Is this something I want to get rid of? Whatever. So let's go ahead and git commit this new change we made, hello.txt, right? Git commit hello.txt -m. We have our second commit. Hand. Yes, sorry.
Is it going to give me the original lines and then the other, or it only shows me one change?
That's a great question, and I'll repeat it just for the folks online in case they couldn't hear. So the question is, if I run git diff on a large file, say with hundreds of lines, but only one line has changed, right? What does git diff show? Does it show all 100 lines, or does it show just the changes? Fortunately, it only shows the changes. So yeah, it is a nice little tool to use. Okay, great question. Okay, so let's go ahead. I'll just finish the git commit, and let's go ahead and then do push that commit to the origin, git push origin main. Great, right? And then if you want to confirm to yourself that it worked, right? If we go to our webpage, there we go. There's a second commit. Okay, so what we've question, yes.
Yeah, why does
You mean like without running git add?
Yeah.
Okay, so that's a great question. So yeah, excellent. So the question is, how come we were able to commit this second commit without staging it first? What that is, the first time we went through things, we did git add and then did kind of the git commit. So this is, you could certainly do, every time you make a change, you could do git add hello.txt and then do the git commit message. For me, there's a little bit of a shortcut here that I happen to use in my Git flow. You can after you add the file the first time, you can kind of skip that git add file step by doing the git commit file name. Yeah. So that's why it's just because when we did git commit here, we specified git commit file name, and I've already added it already. So it's a shortcut. I should step back and say there are many different ways to do these commands with Git. So this just happens to be my workflow, but you can certainly do git add file, then git commit, and then run it that way as well. Another question. Yeah. Yeah, that's a great question. So if you run multiple, when you do git commit, but don't do the git push, kind of what happens, it does store up on your local repository here, right? So, and in fact, I encourage everyone when you're working on a code, you want to commit often. You kind of in different files, you're working on your local repo. Commits, you want them ideally to be as like small a changes as possible so you can track them easier. So let's say we were working on a big coding project. I could do commit 1, blah, 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 commit 2, blah, 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 commit 3, and then I could do one git push at the end, and that would push all the commits up to origin. Yeah, so what's the difference between that and saving frequently? Well, when you save, the difference is that it tracks the changes inside the Git system. Like if you were just saving the file on your local machine, sure, that file is saved, but it's not inside the Git. We're going to talk about a Git commit tree in a little bit with Jason with a Git by hand.
Tomorrow.
Oh, sorry. We'll talk about that tomorrow.
But, like, yeah, you won't see snapshots. Like you're saving with commits, you get snapshots of your different versions of files that you can revert back to. If you're just saving, you don't get those snapshots for free on that.
Yeah. Okay. Excellent. Another question. Okay.
The version history, like on Google Docs.
Yeah.
Yes.
So it is. Yeah, exactly. Right. The Google history.
Google Docs is a version control system.
Yep.
Yeah.
You want to repeat that?
Oh, so the question was, is this like the version history inside of a Google Doc? And the answer is yes. I mean, the version history in a Google Doc, that is a source of version control, and it works quite well. So this is, with Git, this is just another version of source control. But exactly, it gives you those snapshots. And yeah, that shows you how it can be so powerful and so useful. Question on the end?
I make 3 changes, so in each change I make a commit message. But I don't push commit. Versus if I make 3 changes and then do a commit message listing all 3 changes. If I do 3 separate commits, then I have 3 separate versions saved on GitHub versus just one big version saved.
Exactly. So the question is, what is the difference between doing 3 changes and storing that in one big commit versus having 3 separate commits with each individual change? Exactly. If you have it with the separate commits, now you have a separate snapshot at each of your changes. And that, at the end of the day, end of the road, that's easier to debug or track issues that come up. You could imagine if you have you make 3 changes to a code, but there's a problem in your second change. If it's all in one big commit, that's harder to go. You say, okay, I know this is the area where the code broke, but now I have 3 different changes that I'm sorting through to figure out what was the problem. So that's why it's useful to have your commits be short and manageable chunks, as manageable as possible.
I think one other thing that's worth clarifying is that you can git commit without git pushing. So git committing just saves those shaft points on your own computer. Git push will push it to GitHub so that other people can access it on GitHub. So you can do one or the other.
And I guess with that, you should commit often.
Yeah.
Then how do you decide how often you should push?
Ooh, that's how often you should push. So usually I would say, like, if you're working, so this is hard and fast. I don't know if there's any like strict hard and fast rules, but I would say kind of like a rule of thumb is that, let's say you're working on a kind of a feature for a package. I would usually do lots of commits as I'm building that feature, but I probably wouldn't push it to my branch or whatever until the feature is done. But I don't know. That's not necessarily a hard and fast rule. Do either of you?
We're gonna talk about Git flow after this. Is talking about how to use Git in a way to work with multiple people together, and there, we're trying to circumvent like how often you should push and sync changes, because you'll be working on different branches, and the branches will be different from each other, so you don't run into so many conflicts and things like that. But
yeah,
I think it depends on the person. I try to sync as much as possible to keep everything up to date.
Yeah, I also try to sync. Okay, great. Okay, so these have been fantastic questions. I think for the sake of time, I'm gonna push
more questions on Piazza.
Yeah, I'm gonna push through the rest of the lesson for now. But questions, keep them, post them on Piazza, or be sure to ask us after. Okay, this is fantastic. Excellent discussion. Okay, so far we've talked about making the changes on local and then pushing them up to the origin, right? But how do we go the other way around? What happens if a collaborator makes a change to your repo and you want to bring that down to your local machine? how do we do that? Well, let's go ahead and simulate this. Let's go ahead to our GitHub page, right? Here's our repo. Here's our hello.txt file. And just for the purposes of this demo, I'm going to edit this file directly on GitHub. This is not something normally I'd recommend that you do. Again, purely for demo purposes. We can edit this file by going to this button all the way to the right. There's this pencil symbol here. I can go ahead and click that. And I'm just going to go ahead and add a third change to hello.txt. Now, in GitHub, in order to save it to the GitHub repo, right, we click this button, commit changes before. We have to give a commit message, just like on the command line. Whatever, third change. Commit changes. Okay, great. So now we have a change on the origin on GitHub. How do we bring that down to our local machine? Well, we pull that change down using a command called git pull, right? And we want to pull from origin, the GitHub that we specified, and we want to pull down that main branch. And again, you can do this with different branches, but we'll talk about that later. So git pull origin main. You can go ahead and do that, and there we go. We've gotten our new change now on our local. We can see that, there's this third line of text here. Okay, great. So the last thing we're going to talk about is conflicts, right? Because now you could imagine a situation where there's a change up on the origin, on the GitHub repo, on a line of text, but there's also a change on your local machine, right? You could imagine, what happens when they're in conflict with one another, right? How do we merge? How do we resolve that conflict? So let's go ahead and simulate this. Let's go ahead and we'll go back to the GitHub version, right, with the origin. Let's edit this file directly again, hello.txt. Again, we use this button that's the pencil in the corner here. And on line 7, let's just, add some text. So I'm going to say this is the origin change, right, on line 7 of this file. And now, just like before, I'm going to commit those changes to the GitHub repo. Okay, I have to give my message, origin change. Great. Okay, so now that's all set. Let's go to now our VS Code window, right? And we have hello.txt locally. Let's also edit line 7 with a local change. Right? We can go ahead and save that. Now we can pretend, let's say we're going along, we're in our Git workflow. This is a change we want to keep, right? If we run git status, I see that hello.txt is modified. I can go ahead and commit hello.txt. Right, -m, I need to add that commit message there. I'm going to say, here's my local change, right, just like that. Then you can go ahead and hit enter, right? And now, let's say I want to push it up to the origin. I would go ahead and say, oh, well, I want to git push origin main. But now we're going to see something different, right? Because Git's going to recognize, it says, oh, wait a minute now. There are changes on the origin that you haven't synced with your local copy first. That's what this is here. So it's going to say, before you can push, you have to run a git pull to pull down these new changes, right? So let's go ahead and do that. We'll do git pull origin main. And now the code's going to say, uh-oh, I have a conflict. The change on the origin is on the same line as the change on the local copy. And Git has actually modified this hello.txt file to signify what this conflict is. And it's up to us as the users to change, to modify, to resolve this conflict. Okay, so how can we resolve this conflict? A couple things. One thing, you can do this manually. Git will specify using this like greater than head thing, and it's going to show you the changes here. Let's say you just wanted to keep the local change. Well, you could go ahead and delete, everything but the local change, right? And then that would be fine. That would be resolved. I'm just going to undo that for now. You could do the same thing. You could imagine, doing the origin here. But I didn't want to do that manually, though, because, VS Code has some nice integrations here where you can automatically say, do I want to keep the current change, which is local, right? If I click this button here, there we go. Look, I have only the local. Do I want to accept the incoming change instead? That's the thing coming down from the origin. See, changes with the origin. Or do we want to accept both changes? So I don't know. Let's just go ahead and accept the incoming change for, for the sake of the demo. Right. Okay, great. So now we've accepted that change. There's no more of that, all those, the text that get automatically added to the file. Now we can save hello.txt, right? Now we're ready to resolve the conflict in the repo. So how do we do this? Here, we do have to go back and stage the file again. We need to do by stage. I mean, that's going back to that command git add we did before. That's called staging the file. So we will git add hello.txt, right? And the hello.txt has been merged. The merge conflict has been resolved. Now we can go ahead and run a git commit. We don't have to specify the file name here because we've set it up before. We do have to always do that commit message though. So git commit -m, let's say fix merge conflict, right? And now, finally, we can, now everything is resolved. We can git push origin main, and now we're back up and running again. And if we look now, our local repository is now in step again with the origin. Okay. So that is the demo. So I know that was a lot of things I just threw at you, and we had a lot of great questions and a lot of great discussion. But what we're going to do now, and we're running a little late. How do we want to do timing for this?
I think we'll just do this today and we'll do Git flow tomorrow.
Okay, sounds good.
Yeah.
Okay, great. Perfect. Okay, in that case, let's go ahead and take the next 10 minutes. Everyone break up into your groups. And first thing, let's see, can everyone reproduce the steps of the demo that we just did? And remember, if you want to access the demo from the start, right, it's on the GitHub page, code Astro, day 1, git intro. Everything we just did is on this gitdemo.md. So you can kind of type along to that. And if you have questions, please ask your group members and then ask your TAs and instructors. And then if everyone's able to reproduce the demo, we have a challenge activity for you. And that's choose a group member, have everyone in the group clone that group member's repository, and then try to edit the same file at the same time and then push back to the origin. This will cause conflicts, though, will cause a lot of conflicts. So can you work together to resolve these merge conflicts and bring the repo back to order? And just a quick note to do this, the owner of the repository, you will need to add your group mates to give them permission to push directly to your repo. And the way you do that, if you're on your repo here, I think you go to, that's right. There's the settings button, and then you can click collaborators. Oh. Then you have to be logged in order to do that. And then you can add people here with their usernames. Yeah. So that's the activity. And I'm going to leave here on the screen. I'm just going to leave a quick summary sheet of different useful Git commands to help you as you go along. So please be sure to ask us questions if you run into any problems. So thanks. Okay, everyone. Okay, let's bring it back together here. We're about ready to wrap up for the day. And actually here for the wrap up, I'm going to pass things over to Jason. Yeah.
Hopefully you guys had some great chaos in your Git commit histories. You might be like, I don't want to do this. This is a pain. On top of Git to try to avoid Git conflicts, basically. And it's a how do you develop with multiple people with Git in a way that prevents conflicts from happening. So we'll be talking about that more tomorrow, but we'll just wrap up for today. So let me just share my screen. Okay, and go to slideshow, closing slides for day 1. Just a reminder, we have a class source vocab list. So if you go check this out, is on our list of, you can find this in many different ways. One way you can do this is if you go to our day 1, you should be able to find all of our various slides, including the closing slides, and you can access the class source vocab list from there. Just a reminder, by the end of today, our goals is to identify which development environment is most appropriate for your programming task, decide when and how to use functional and object-oriented paradigms, use Git to contribute to version control code. And we didn't quite make it to Git flow, but we'll cover that tomorrow. And just a reminder for your project goals is what you'll be working on asynchronously for the folks remotely, or this afternoon for the folks here in person, is to decide on a purpose of the package and write one central function or class. And we also, in our main README, we have a nice project timeline example that one of our head TAs, Kruthi, wrote that I wanted to point you all at. If you go back to, that's not it either. If you go back to Code Astro and go down the README, there's a timeline time expectations. It gives you a sense for what kind of what you should try to do in each day, and it also gives you a sense for what to expect in the next few days. So just the emphasis of roughly how much time you have each day. If you're going to take Wednesday off, then between day 1, day 2, and day 4, how much time you have, and we'll be doing lots of other things in the next few days, and you'll be probably wanting to do those things. So don't try to make an extremely ambitious project. Just try to get one piece of functionality working today. It's kind of our main suggestion here. So I encourage you all to take a look at the timeline and time expectations part of the README to get a sense for what's going to happen in future days, to get a sense for how to scope this project that you're going to do this in this one week. Okay, let's go back. Oops. Okay. All right. Also, when you're picking a name for your package, check if it exists already on pypy.org. Otherwise, you'll have issue uploading your package to pypy because there's already a package. It's first come, first serve. Just a reminder, we have two optional lessons today. We have a 3 to 4 p.m. Pacific time here and on Zoom. Using the same Zoom link, we'll have a lesson on the basics of machine learning. And then 4 to 5 p.m. also here on Zoom, we'll have a lesson on vibe coding, on the basics of vibe coding. Okay, I just wanted to end with don't apologize for everyone that's here. You all belong here, and this workshop is for you. We have people of many different skill levels and many different programming backgrounds. So, but this workshop is for everyone, and use the resources and materials however is best for you. We try to purposely have materials at a bunch of different kind of levels. So hopefully, wherever you are at in your programming journey, you'll find some part of this workshop that's useful for you. So, and this is not a class. We're not evaluating you. There's no grades. It's about you should take out what you want from it, and we're just trying to help you learn. So, take what you want to get out of this workshop, and everyone here. Everyone here belongs here and is and hopefully can get something useful out of this workshop.